when she first suggested looking into what she's doing, I remember thinking in the back of my head that this is a deep, dark hole that she may never come out of. And so in some recent meetings that we've had,
So we are waiting on batteries. We cannot start until we have batteries for the clicker. Coming. So for this seminar series, something we like to do on occasion is to invite CLAB alumni that have done very well for themselves to come over and tell us about what they are doing. And we do it for a couple of reasons. First is because it really feels good to see how former students, the CLAB, how they are doing and how successful they have been, and that kind of thing is really rewarding to all of us. And the second is basically for you, grad students, so you can see some examples about potential work avenues as you graduate and get into the work market. So today we have a perfect example for that. Dr. Matt Johnson, who has I cannot see anything. I need my cell phone now. No, I can see that. Thank you. So Matt has a colorful career. Has done a lot of things. He first got a PhD here working with Ken Heck at the Sea Lab, and then he postdoced with Sean Powers. Then he moved to a second postdoc at the Howard Research Institute in Corpus Christi, and then he joined the National Park Service in Gulf Islands in Mississippi, working as a marine ecologist. Then he moved on to the Bureau of Ocean Energy Management, BOEM, where he was a marine biologist for a while. And finally, he went to Florida, to Miami, to work for NOAA at the Southwest Fisheries Science Center, where he's the lead for the Coral Ecology Group. So as you can see, a pretty diverse career. So basically, he has a lot of experience in marine ecology, broadly defined, and particularly putting it to work. So basically, the applied aspects of a bunch of different topics in marine ecology. So anyway, we thought that it would be great to have him over today so he can tell us about what he's doing and also tell you some leads, if you will, for you grad students as you are pursuing careers once you leave us. Okay? And please make us look good. All right, Matt, thank you for coming.
Thank you. Is this working? I have my Britney Spears microphone on. but no dancing, absolutely no dancing. Okay, so my name is Matthew Johnson. I'm with the Southeast Fisheries Science Center in Miami. I work with the Coral Reef Ecology Group. I'm the unit lead there, and I'll sort of get into what that crowd is, but the title of my talk is Math Monitoring Muttons in Mayhem. So sort of summarize up what the National Coral Reef Monitoring Program is, because it's a relatively new federal program, but it's also something that is really applicable. A lot of the techniques that have been developed can be used well beyond just the Coral Reef program, and we're going to talk about these a little bit today. I'm going to try to keep it not super data heavy, kind of more of methods and sort of some of the products that have come out, and see how the program works. So, let's see. In reality, that's what the title is. This is a very large program. We've got lots of partners. It's not just me. I work with James Bonzak. If you guys ever use any sort of fish counting methods, you've probably ran across a lot of his work, as well as Laura J. Grove, who actually came from the Auburn side, the other side of the bay, and of course Steve Smith and Jerry Alt with the University of Miami. And there's a lot of other folks at the national level and with other agencies, but it is a huge collaborative effort. Again, many partners. We work on the reef track all the way from north of the entire Florida reef track all the way down into the Caribbean, Puerto Rico, St. Thomas, St. Croix. And we work, so that entails a lot of folks. Everybody's interested, everybody wants to know what fish they have, how their habitats are doing, and we're sort of the vessel that's providing the framework to get that information to folks. The Park Service is probably our primary partner. They're, of course, responsible for the work in the Dry Tortugas area as well, which is if you have a chance to go to Dry Tortugas, is a phenomenal coral reef, one of the few left on the Florida track that's pristine. And yes, I am an alumni, so this is out Big Lagoon, using shapes and sort of the underlying theme throughout my entire career has been the role that habitat has played in the ecology and how that interacts with fisheries and organisms, and how to sort of translate that up into management type issues. So I spend quite a bit of time in the water with the suction sampler, the Wand of Death, in Ken's lab. So I wouldn't be surprised if those things are still around. Are the stars still sitting somewhere in storage somewhere? On the hill. Okay. So this is our group, more specifically, sort of take it down to national level. This is my group in Miami. I'm the unit lead. Laura J. I work with her. I handle a lot of the getting stuff to where it needs to go. She handles a lot of the coordination, trying to get all these partners lined up and everything in order to collect all the samples that we do. James Bonzak, he's a supervisor. He sort of heads up everything and was really responsible for the fisheries independent monitoring that occurs with NOAA going all the way back into the 70s. And then Dana Williams, we used to have, if anybody's familiar with a scientist named Margaret Miller, she used to do coral work, coral restoration stuff. She has recently left us, and Dana Williams is sort of taking her place, doing the coral ecology side, the actual, can we plant, can we breed a better genet of coral to be able to facilitate restoration? But again, trying to keep everything applied and move it along. All right, so again, here's our program objective is develop applied research. That's really what we want to focus to. It's like, I'm from the government, I'm here to help, right? So we actually are trying to do that. Most things go to Washington, D.C. and become bad ideas. This one actually has remained a good idea through time. Everybody, this is what we want to see. Unfortunately, this is what we have to deal with often. If you look here on the bottom, these are patch reefs. These are all the boats parked on top. This is down in the Keys. So this is what we have to deal with on a regular basis, and this is extremely hard on a very sensitive environment. So what we have in the Miami area is continued growth to a part of the state that's going to disappear in 100 years. People are still moving there for the time being. We've seen around somewhere in the neighborhood of 5% growth in most of the counties. And that puts us at around 7 million people right now on a 100-mile stretch of coastline. And it's really, really populated. And of course, we're bound on the west by the Everglades, so the population gets denser and more dense the more people who move in there, or they build up. But either way, you still have a huge amount of pollution, you've still got a huge amount of runoff, you've still got lots of people that just want to be in the water. So, if you're not familiar with the reefs in Florida, as well as the Caribbean, the reefs are having a lot of trouble. There's been some major losses of our acroporid, our staghorn, and elkhorn corals. We've got a blight that's going through our pseudoastias right now and really chewing up and killing. So we're seeing a major loss of the framework building corals that have really built the entire ecosystem and a lot of the fisheries that depend on that ecosystem. Of course, you've got climate change. There's a coral reef watch predicting how hot the water is going to be. Poor water quality. If anybody remember this last summer or 2 summers ago, the huge giant algal blooms that basically shut down all the beaches north of Miami, pretty much down into the Keys, because of the green sludge that was growing on everything. It was awesome, all having to do with they believe the sugarcane production in the central part of the state and the nutrients flowing out through Lake Okeechobee not being filtered processed. So there is a huge need in that area for figuring out a way to better filter water and move it out of the lake system. Of course, we've got destructive fishing practices, especially like in the dry Tortugas in the southern Gulf. This is a recent picture. They will drag nets like that and destroy the coral to make soft bottom for shrimp, and they can come back and shrimp it. They'll basically drag that net until it tears off, and then they just keep on going their ways. And of course, and especially in this area, and we've of course seen it in many other areas, is the fish-related ecosystem design, redesign, not design, but redesign, that essentially as you harvest more and more fish, especially as you implement limits, you start changing the phenotypic capabilities of the fish. Ultimately, you're going to get a fish that looks nothing like, you have a population that looks nothing like what a regular population, an unharvested population should look like. And that, of course, cascading effects throughout the environment. This is something that we've seen. This has been some of the primary reason, and this is, of course, has happened around here as well, is this was typical catches in the Miami area and the coral reef area for decades, where the blacks and the Warsaw's, big giant groupers, fish you don't see, although you can see some of the Goliaths now that they have been, is this working? Hold on, okay. Also the sharks. Does anybody know that the largest great white shark ever was captured in the Florida Straits between Cuba? And I'm pretty sure this is Ken and John back here. Right back there watching. So, the dynamic duo. So that was they never got an official weight on it, but they think it was in excess of 3,000 pounds great white when they roamed the ocean everywhere, not just in limited areas. And of course, this is Elvis's brother. He showed up. He liked to go shark fishing for a while as well. So, but we see that all through this area as the population increased, the harvest increased, and the over-harvest increased. There was a really good paper that was Lauren had put out that was extremely good. And of course, that led to similar papers from this area, from the Powers Lab, sort of documenting this change in the large predators over time using non-traditional methods of data collection, which has been extremely good and helped provide very good sort of baseline or standards of which we can look back on issues. So, what is happening? Finally, coral has a big problem because there's always an argument. Is it coral? Is it a habitat? Is it an organism? and it's both. And oftentimes it's conveniently one or the other when you want to get your point across. You know, when you want to do restoration, it's not an animal. Do experiments or manage species, then it's not a habitat. And the real goal is to try to marry the two and get all groups to understand that it's both, and it has to be treated differently than, say, a Spartina marsh would be as well. Not either as good or bad, sorry, Juiced, but just differently. It has to be realized that its habitat benefit is there, but also its benefit as a species. And of course, there are many, many moving parts, all the way from multiple predators, we have invertivores, grazers, and of course keeping the settlement going. And again, we get back to this picture because this is where we want to try to get it back to, and right now it does not look like that outside of a handful of spots. As a matter of fact, I did a lot of diving after Irma, doing triage for some of the areas, and it's pretty amazing to see a big giant 20-foot tall coral to have the whole side blown out where the sandblast had just gutted it and ate the whole inside out. So, the National Coral Reef Monitoring Program. Unlike most ideas to go to DC, this one turned out being good. Basically was originally developed as a earmark. It was an earmark for the folks in Hawaii. And luckily, somebody with a little bit of a science background said, hey, we can take this and expand this and make this nationwide, and we can really take the information that they're gathering and distill it up the chain to be able to enable our managers to make good, sound decisions and have a good understanding of what's going on in the coral reef. And in the process, we will create enough information where our partners and the on-the-ground managers and scientists can use that information as well. So it was formed in 2013, and again, it's a strategic framework, and again, trying to give a snapshot of what everything looks like. I work up here, Florida, and the Virgin Islands, and the flower gardens. I forgot about the flower gardens. And essentially, we have a 2-year cycle where 1 year we work in Florida, the next we work in Florida and the flower garden banks, the next year we work in the Caribbean. So every other year we do a massive large-scale assessment of all the corals and of the coral reef fishes in the area. And these are their goals. There's a very pretty pamphlet, if you're interested, that can be downloaded, really easy to find. But some of the main things, we want, obviously, sound data. Everybody wants that. And that's extremely hard sometimes, especially in a monitoring framework, because monitoring programs are notorious for collecting data and more data and more data and more data, and it sits on a shelf and nobody does anything with it. Develop consistent and comparable methods, and this has been a real struggle. Has led to a lot of infighting in the group, like any program that's managed responsibly. And we finally got to the point where even with what we're doing in the South Pacific, our methods may not be exactly the same, but they're at least comparable. And the metrics that are being created out of it are comparable among all the different habitats. Of course, provide periodic assessments, deliver data, develop strong partnerships. A lot of people have interest in the coral reefs, and of course provide context for interpreting what's going on locally. And that's really the big push, is to not only give the folks on the National Resource Committee and Congress information to make decision at that level, but also give information to the local manager that says, hey, why is my reef dying? Why is it I've seen a change in fish species? So we have areas. Coral and benthos is, of course, the primary one. We have reef fishes. We do assessment. We also do climate impacts. We've got a whole arm of this program that does nothing but monitor the changes associated specifically with climate change. A lot of, especially trying to do what we can to, for lack of a better term, assist evolution, to allow the more hardy species the opportunity to move into new areas and to facilitate growth. And of course, we also have Socio Economics, because the coral reef, the coral reefs drive a lot of these economies, especially when you get into the Caribbean. so much food production comes off of the coral reefs, and of course that's what's led to the destruction of many of the fisheries populations down there. But also, if you work throughout the Florida Keys and the Miami area, there's a huge tourist business. There's more dives that go out of Key Largo, I think, than any other place in the world. It's fast, it's easy. The reefs are neat to see, and they're only a couple miles offshore. So this is sort of their management framework. They paid a lot of people at UMC's a lot of money to come up with their wedding cake, you know. So essentially it goes up to down, provide a lot of information that's good for the scientific. It gets a little bit more, you know, less precise and more, or less data heavy, you know, so you can get your local work done. Again, stakeholders, a little less science deep, and of course all the way up to the policymakers. So we're trying to run the gamut and get everybody online and at least able to understand accurately what's happening within the environment. So we put out a whole series of works, and we've got an army of people that works on this sort of stuff. Our Florida Reef Track and American Samoa, these are our draft report cards that are getting ready to come out. And of course, this comes back to, the reason this is a question mark right here is something that, of course, everybody around here should be taking into account, is the lack of baseline monitoring. So we've had major problems with trying to develop metrics because there's no baseline monitoring. At least that was done in a consistent manner, in a way that could be interpreted to compare to our methods now. So starting in 2013, we really started ramping, or 2012, started ramping that up and collecting this baseline data, so we'll know. But how do you grade how the coral reefs are now when you can't prove that they were awesome 100 years ago? That's a perpetual management issue. Of course, at the scientific level, we have sites. CORUS is our main repository. All of the data we collect, it goes through, it takes about a year to go through the QA/QC process to get it entered. It's really hard to get graduate students in the Virgin Islands to enter data. Who would have thought, right? They've got better things to do down there. But it all goes in here, it all gets reported, it all is publicly available eventually. And of course, we pull from it and we publish from it as well. Some papers here that have been published in PLOS over the last few years using our data. We have actually quite an extensive list, especially for the Florida track coming out of Jerry Alt and Steve Smith's lab out at University of Miami. So sort of the mid-range of these assessment reports, this is where we went and this is what we saw, but not really data heavy. So, overall, at our level, what we do is we have two different aspects of our program. The first side is the coral monitoring, the fishes and the coral monitoring. The coral and benthos is what they called it, and of course the fishes. And we do this sort of collaboratively where we in Miami are responsible for the fish side throughout the Caribbean. So we organize that crowd out in the field and collect all the samples we need. And the NCOS, National Center for Ocean Observation Service, I believe, services, part of the National Ocean Service, which is another branch of NOAA, which is not necessarily fisheries derivative, like our branch. All that, and they do all the data processing, and we marry the two together back at the end. But this particular, what I like to call a mathematically driven adaptive monitoring program, and provides a comprehensive sampling framework to sample an entire ecosystem, so large scales. So it's not like we've got a reef out here in the bay, and you can go and monitor that pretty straightforward. We're dealing with hundreds of miles of shoreline that have to be surveyed, as well as multiple islands and multiple locations. And it's not even bad for us in the South Pacific. They get on a ship and they leave for 4 months on the white ships. And they're gone. And they have a whole team of technicians, and that's all they do is they ride from taking samples all throughout the coral. And that's a great opportunity if anybody ever wants. Simply, what we try to do, we figure out who's this, and then we relate that back to its habitat, what's the variance in that habitat, and then we allocate accordingly. And this allows us to work through a massive area, but it also comes with some caveats. And our metric, our currency, if you want to call it, is our so it's sort of similar to your sample, your ratio of the standard deviation to the mean. That's all. So sort of in a chart flow, the program is very heavy in this pre-survey sampling design and analysis, primarily because it has a very strong feedback loop that allows adaptive capabilities. So each year, the survey is not going to be the same. It's going to have to do with how strong and how the quality was of the data the year before. Test. Okay, there we go. So this is essentially, this particular program is very, has a lot of work that goes in it before you even start sampling. And really what that relies on are maps. And this type of program could only be developed once we had the ability to start collecting the aerial photographs, the LiDAR data, and cover huge swaths of seafloor. And luckily the water down there is clear, and we can use a lot of our aerial imagery to classify our reefs. And then of course, as we move along and every time you go out, we have a feedback mechanism that allows us to ground truth as we're going and compare and make sure our classifications are the same. So we can always come back, and every year the map improves a little bit, and it gets a little bit better and a little bit better, and theoretically we should be bringing that coefficient of variation down at least to an acceptable level. So this is an example of at least the way we run it in Florida. This would be the Keys right here, the islands. Of course, Hawk Channel is the mid-channel, sort of the mid-reef channel that a lot of the vessels, with a huge amount of boat traffic that runs up and down through this area. And then the reef track. So we have mid-channel reefs, we have fore reefs, we have deep reefs. But the actual classification is not super important. It's just that you have a framework, a consistent framework for looking at these habitats. And the reason this is possible is because we put a lot of effort, and basically the years before this program got off the ground, there was a lot of work that went into identifying that reef fishes, especially coral reef fishes, are so habitat driven that you can basically classify the population, the habitat, by the population of organisms that you find on it. So what you're going to have up here in a pinnacle or a patch reef is going to be way different than what you see on your low relief bottom. We call this pavement often. So the suite of species is going to be totally different. But because you can, and we've shown that you can marry the habitat with the species composition, then you can then turn it back and do your sample allocation based on the variance within those habitats. Okay? So have y'all got a survey design class here yet? Statistical and ecology design class yet? We're having it. That was something that I know there was a push for many years, but an experimental design, a sampling design framework type class. So this is basically what we do. We have the entire 500 square kilometers of the Florida Reef Tract, as well as the Caribbean, divided up in all these little squares and classified as what type of reef it is. And again, these are 100 by 100 meter squares. And this is Key West right here, if anybody's been down there. And essentially, each one of these different colors is a different habitat that we sample, and then of course we come back and based on the variation of the fish species within those habitats, we can come back and base the number of samples that we take on that. So now we get into sort of where we're at before the start of the year. So in the past, as we get this program off the ground, we really didn't know what a lot of the variation is within the populations. We know that there is variation, and we know that all these species are out there, but nobody had looked enough at them enough to be able to say, okay, we see these major swings every 5 years, 2 years, 3 years, daily of the fish populations. So what we did is we spent the first 4 or 5 years using a straight random sampling design. So we know the habitats, we know how much area it takes. We can come back and randomly sample throughout that habitat. And as that data set builds, this feedback loop gets us to where we can move into something called a Niemann allocation or optimal allocation type scenario, where we can take the variance of the populations of the organisms and then apply that back to how much you're going to sample in that particular environment. If you've got an area that covers a lot but has almost no variation in your fish population, you don't need to spend a lot of effort sampling it. You can allocate resources to more variable environments, typically like the pinnacle reefs, and you can move forward. So a short stats lesson. Does everybody understand the central limit theorem? Yes, there's a few nods going on, but essentially, especially as every grad student is stressing out over how many samples to collect or how many experiments to run, this is the idea here that the more you do something, the closer to the more consistent it becomes, you know. So at some number, and typically, especially for experimental stuff, it's somewhere in the neighborhood of 30, you start getting relatively close to the mean. But of course, the natural environment is much more complex than that. So this is very critical because this is our variance. Variance also follows the same trend. The more samples you take, the tighter your coefficient of variation is going to become. So a little bit of statistical design, sort of what I had mentioned earlier, that typically in a mesocosm type experiment, which by the way looks really good over there, y'all's mesocosm stuff, your setup. I wish that was here when I was here. But you just take, or you could do this in the environment, so this would be just a regular sampling. You go out and say, okay, we've got the reef, we're going to pick 5 areas and we're going to watch them all the time. Well, you've always got a problem with that because you might not have the right kind of habitat in that area, and it's just at the habitat scale, and we're working at the ecosystem scale. So ultimately you get into a scenario like this where you can clearly define your habitats rather than just taking a random area, a random round spot. And of course, then you can come back and allocate it again. So say this habitat right here has got low variance, so we don't need a couple, where this right here would be, say, something like our pinnacle reef, where you've got a lot of variance within the environment. You would need to sample almost all of it. And as a result, we can get tighter and tighter coefficients of variation. And this is what it looks like when you map it out. This is actual data from our Blue Tang and St. Croix in 2012. So as we were working through our allocation process. So you can see here when we use our simple random sampling, would be this design, and you actually can map out your sample size versus your coefficient of variation using the actual data that has been collected for a couple years. This is the curve we get. So we're looking at optimal allocation. So somewhere along this curve is going to tell us where a lot of sampling effort gets you very little change in data. Okay, so what we want to see here is when we shift from this randomized sampling to stratified random sampling, where we're basing it on the habitat-specific coefficient of variation, that this line shifts, and this is our increase in precision. It also allows you to operate, especially with fixed budgets, at a much at a lower sample size, because sample size means money. So you can get to this inflection point right here. So incidentally, In 2012, I think that was the first year we had decent habitat data down there. And even though we had done the stratified random sampling, we still ended up here because there were so many problems within the habitat data. But over time, this has actually increased and moved. I think last year it was right in this area last year, right where it's supposed to be. So it's sort of proof positive that what you're doing is working and you can move forward. So here's a little bit of the math. So quick look. Okay, nobody stress out. I see eyes glazing over. There's a little code to go with it, a little R code. If you don't know how to code in R, I recommend that highly because there is so much stuff that's going into the requirements nowadays as if everything becomes more and more mathematically driven. And we're out of the math part. Okay? Big sigh of relief. So now we conduct the survey. Okay? Our survey basically consists of multiple divers going in and sampling sections of the water quality column. So one of the big things that has gone on in this particular survey is the use of a belt transect versus this RVC methodology. So, and again, this is how federal agencies work and how things function together. Everybody has their way. We come out and everybody argues for 2 years and eventually works it out. And this RVC method ultimately has won out because it, in the end, is much more effective for sampling fish populations that are commercially important. Belt transect divers have a tendency to keep their nose on the bottom and not see the giant snapper or grouper swimming over top. Oop, wait a minute. So how do we get this to work? All right, so what we do, and this was put together by Florida Fish and Wildlife. They have some technicians with plenty of time on their hands. We show up in a boat. We drop a pair of divers into the water. They basically swim out around 7.5 meters, both creating a cylinder. This is theoretically the way it looks. Oftentimes, if we have low visibility, we can take that down to 5 meters, and we can also overlap circles. They spend the first 5 minutes basically writing like mad, because during that first 5 minutes, you take and you count, or you identify every single species you can. But as soon as that 5 minutes is up, then you go into counting them. So you ID and then you count. But also while you're counting, you're also identifying new species, because we use those on the biodiversity side. But on the actually abundant side, we just use the fish that you see in the first 5 minutes. And that's, of course, to account for the amount of movement that reef fish have. They move, they have fins, will travel. And then the diver will come in and do a benthic assessment. And this is one of our feedback loops that my technician will come back in and say, what did the diver look at on the habitat? What did he write on the data set? How did he classify it? Then we also have them take percentages of we have them take percentages of what is here and there, because you can tell a lot of that, be able to reclassify your data to further refine those maps. In the Caribbean, we're working on 50 by 50 meter scales. In the Florida Reef Track, we're working on 100 by 100 meter scales. We're trying to get it down to 50 by 50 as our maps improve, and hopefully we'll get there soon. This is what our divers look like, hauling a load of gear in the water. But this is our all-purpose tool. You use that to measure fish or to hit your partner to get away from the sharks. Camera. The one thing we do that is really good if you guys ever work with divers is we sync the GPS watch with the diver's watch, and we keep track of it. So that is another feedback loop that we have that oftentimes, especially when we're working in high current areas and we're dealing with 100 by 100 meter grids, sometimes the divers can't get in the water fast enough to move off that spot. So, or they go underwater and they can't find the habitat, they're searching for the habitat, they finally find it, but they happen to be out of the block. So theoretically, we can come back and look at what time they're in the water and look at what time the position is and see and where the position is located once that buoy stays in one spot for a period of time, and we can say exactly where you were, and this is the habitat you were supposed to be in, and this is your classification, and let's tie everything together and reassess how it works. So that's an incredibly useful tool. This is what our selection, this is in our 100-meter grid. So what we found is during the first several years in Florida that we were having a problem. We could not get our coefficient of variation down working on a 100-meter time frame, or 100-meter frame grid size. And we had a lot of problems because a lot of times, you'd have the habitat would go through here, and if you drop the divers off over here, they're randomly going to some location in that quad. They're missing the habitat. So we were having huge issues with a lot of the species having a high amount of variance. So we figured out that either reduce it down to 50 meters by 50 meters, or you double the amount of divers in the grid. So now each time we go out and sample one of these grids, we put 4 divers in the water. So we have a 5-man team, 1 person on the boat, 4 in the water. And oftentimes we'll have an additional 2 benthic divers with us as well. So they will be doing the coral surveys concurrently while we're doing the fish surveys, sort of get everything knocked out at once. This is what it looks like. This was 2014, and this is basically what it looks like every year. We do a huge amount of work at the dry Tortugas, especially working with the monitoring program with the National Park Service. And of course, all the way up north of this would be the Miami area here, and working way up into what we call the SEFCRE region, South Florida Coral Reef Initiative. But there's a major change right here in the reef type, where you get this broad reef building type reef all through here. But once you get north of here, it's a completely different high current, sort of a low relief type reefs. That is because the Gulf Stream swings in right here, and they deal with current a lot more than what we deal with down here. That's a little bit of the mayhem. So again, we come back to the adaptive precision. This is what we do. We sit down and start crunching numbers, and we come in, and this is what it looks like. It's a lot of numbers. There's not a quiz on anything, but essentially what you get is we look at, so this would be a 10% coefficient of variation, 15 and 20, if we do it both directions. And you can see, so this right here is our blue tang. Our blue tang that was in the other slide, except this is recent data. You can see here for a 15% coefficient of variation, we dropped from having to collect 384 samples to 176. Okay, so as part of that, we can of course reassess and trade among species to be able to maximize the whole survey for the most species we can. And typically, of course, there are hundreds of species we deal with. We primarily have about 8 that we focus on, because we found out that with these 8 species, if we sample these guys good, everybody else is fine. So we concentrate on that, and that way we can walk back and forth. So from there, we take in, we come into here. This again would be our blue tang, and these would be all of the different habitats. As you can see, the hard, deep habitats, you don't ever see a blue tang. Why sample there? There's no need to worry about that. Again, hard, soft as well. And we have, it's standardized, it's weighted standard deviation is ultimately, so it's weighted to the amount of habitat present. And we take all of that and produce these right here. So we will come in and produce these allocation curves. Again, this is for 4 species. I didn't throw the whole suite up there, but allows you to look at 2 different ways. If we have a flexible budget, which does not happen, we get a set amount of money and we have to make it work. This is not the way we use this down here. But if you had a flexible budget and could say, all right, we're going to need 400 samples, and we can get all these guys. We can get the coefficient of variation down to I think this is we can get it all down to 15% is what our target is. I need 390 samples, something like that. So in reality, this is what we've got here. We've got a fixed budget, so we've got to find the best break point to maximize for all these species. And of course, that's a lot of work, and depending on which set of managers think which is important, that always comes into play. And ultimately, this is what's produced. This is all of our species with all the looking at the variation within each of the habitat types. But this is really what ultimately happens in the end, is we get this is how many samples we've got. This is how many samples to what we end up with for being able to sample all 8 species to get everybody to a 15% variation. And of course, we only have money for 250 samples. So now we typically come back in and do it proportional to the amount of habitat present. So if you've got, this actually is pavement right here, deep pavement. There's no need to collect 152 samples on deep pavement. We know that the variation is pretty low. The problem is it covers about 80% of the seafloor in the Caribbean. Thus, it covers a huge amount of area. It's going to garner more samples just because it covers so much area. So you can pull this back and we go into, what we call horse trading. We all sit in a room and we all argue about what the sample size should be, and based on all of these curves for all 8 species. So it's an iterative process, and each year that we go through this proportion will change as maps become better, and the number of samples required to get you to your coefficient of variation of concern changes as well, because a lot of times, you'll zone in on where a fish is, or get better at counting it. Sometimes you'll have a better group of divers. And then, of course, where do we go from here? This technique is extremely good because it allows design-based estimates to go all over the place. So, length-based fisheries independent metrics. That's one of our main things beyond just being able to provide managers their information. This is where we're really going right here. We have done a lot of work documenting the change in the population, especially lengthwise. But we're also working trying to make sure that our stock assessors, the whole other side of the building from where we work, they ingest data and spit out numbers. Terrible life. But we're trying to make sure that what we're doing is applied to them, and they can take the numbers and translate that into a stock assessment. And that's oftentimes what is missing in a lot of the data collection that occurs is nobody sits down with a stock assessor and says, okay, if I have all this stuff covered in this manner, I can absolutely work it into it, or at least attempt to work it into. And that's really what we've done. Of course, we use it for management evaluation and efficacy of ecological reserves. Everybody wants to know, especially in South Florida where the reserves are sort of taboo. I know they've talked about reserves up here, off-limit areas in the northern Gulf, and it's kind of been like a keg of dynamite, from what I understand. But everybody wants to know how well is your no fishing area working? Is it actually contributing to the population? Even though you might not be able to see it immediately, is it actually working? Island-based fisheries management. If anybody wants a career path, that would be it. We have a huge need to understand the Caribbean fisheries. Essentially, they've eaten everything down there, and are not very good at collecting data. So we are actively working to designing new ways to look at island-based management systems. So we've taken the island around St. Thomas, and they will have their own set of stock assessments. St. Croix will have their own set instead of doing the entire Caribbean together. And that works out really well because the populations on the islands are much different than each other, and the harvest techniques are often different, and they don't usually get along either. And then, of course, we also, one of the good things that we've seen is we've been really good at quantifying ontogenetic shifts in habitat use. That's often missed by using fisheries-dependent data. So here's one of our, say I promised you Mutton Snapper, so here's our muttons. So here's one of our projects that we did for many years. So this is a dry Tortugas. They decided they wanted to create an ecological preserve, a natural area. So it's off limits to everything. This block right here. This is open, so you can fish in here, and this is the national park. This is a no-take zone also, but this is the national park, so that you can enter in that and do a certain amount of things in there as well. So, Mutton Snapper are the red snapper of South Florida and the Atlantic. Okay, they fill that ecological niche that red snapper fill over here, and as you see, they look almost identical. The dot's a little bit bigger, I believe. And they look a little longer when they swim by in the water. They don't get quite the shoulders that the red snapper get. But again, essentially they fill the same niche. And of course, they have a major problem is that they get big and they're tasty. And they're easy to catch, right? So mutton snapper have been wiped out. They have just been hammered and hammered for decades and decades. So it got to be to where in the early 2000s, a real problem, and the fisheries they were worried were close to collapse. So they decided that what we want to do is look at making this a preserve because we know we have plenty of fish out here. So let's make that a preserve. It's hard to get to. Nobody goes out there. So let's see what it does. But as part of that, we've got to figure out how to measure that. We can't just say we're going to make it and this is the word of God. You can't go in here anymore. We've got to prove to the stakeholders and the consumers that this is benefiting the public. So what we found is after 10 years, this was our population of mutton snapper. The black snapper, so the yellow data is the old data or no fish, and the black are very high density. So that same holds true over here. So as you move back and forth, you can see that by simply limiting harvest in this area and this area, and I think it was restricted in there as well, that the entire population was able to rebound over that 10-year period. To boot, what gets even better is we figured out that we also saw that trend in multiple species as well, especially the black grouper, that of the 4 species where we find a lot of adult spawners, that the dry Tortugas makes up 22% of our sampling frame, but contained 30 to 50% of the adult spawners. Okay, so that really highlights how targeted management of particular areas can really enhance a population. So essentially what happened is most of your spawners are out here. You want to protect this area because Gulf Stream strolls through here, picks up larvae, and deposits them all along the east coast of Florida and the Florida Keys. So that's one example of where our work has been used. Another, again, is this ontogenetic. For many years, gray snapper, mangrove snapper were based on fisheries-dependent data. Nobody really knew where the little guys were. And this is the population structure that they were touting, sort of like this. Once we got involved and were able to look into more of these samples in some of these inshore reefs, we found that the population looks more like that than that. So, and then you combine the two and you get a little bit better image. But the main thing is that you find the species all across multiple habitats, which is incredibly important and greatly stresses the need for ecosystem-based management of resources. You can't just take one piece and expect the puzzle to put itself together. Again, more areas, you can see multiple species. This is looking at the difference between exploited and unexploited species. So obviously if your management area is working, you would expect to see your exploited species go up, which we see here. And your unexploited species down here not really change much. So these 2 are unexploited, these 3 are exploited. So we can say, yes, over the next 5 years we saw a positive impact in this area. And it's working. So here's a little bit of the mayhem that I was talking about. This is a very expansive program, and what we've seen over the years is a steady increase. So the survey was actually started in 1979 by, as a matter of fact, Jim Bonzak, who's still there. They sort of developed the technique, figured out that the 5 minutes is about, they tested a whole bunch of different scenarios and different types, and went back and were able to build it up, and then started surveying. Of course, this was just 4 reef areas. They were doing all the work to develop what they call SPAs, but special protection areas, reserves, preserves, no-take areas, no-go areas, all throughout the Florida Keys to be able to identify the habitats that could have a nice spillover effect for saving a much smaller area than you would think is possible. So that's sort of where the program started, moved along, started expanding here. When they decided that, hey, this is working really well and we're getting great data, let's start looking at the whole reef. And they started moving away from just these high density areas high coral areas to get into more of the regular flat coral, the different habitats. So they were spent a lot of time in the pretty sites here. This was science in the 70s. If you look at the pictures of these guys in here in the 70s, they're all in shorts, drinking beers, sampling, right? Yes? I've seen the pictures. But as it increases and the quality of science increases, obviously the amount of effort and work that goes into it increases. So things got more and more rigid, more and more scientific until about 2001, where our current survey is. Again, it was pre-NCREMP, so we were doing this survey in Florida beforehand. And essentially from there, it's just gone up and up and up as we've increased the amount of areas. So as you can see, this is over, in 2014 we had well over 2,000 sites, individual sites that were sampled, and that's just South Florida. That's not even talking about the Caribbean. So this year coming up, our 2018 dive schedule, we're going to have, in the dry Tortugas, we'll have 22 diving days with 18 divers. We'll have 1,740 individual dives that will occur over a 22-day period. It is wake up, dive, get out, dive, get out, dive, get out. Every team gets 4 or 5 stations a day, and we leapfrog all around the dry Tortugas nonstop for 22 days. But as far as Florida goes, we'll have 3,360 individual dives, of which my group, we typically handle about 300 fish dives and about 50 coral dives. So just our team will basically be out in the water the entire time. So it's very expansive. This is actually, we're moving boats. This will be our new boat this year that we'll be working off of. And these are some dry Tortuga pics. So with that, that's sort of our program in a nutshell. It's extremely chaotic, and these are actually some of the pictures I took this year. I actually got to see my first manta ray to hit me in the head swimming through the water. Some very cool pictures, some very neat corals. But it really highlights the need, and there really is a need for up-and-coming scientists to be able to build on the baseline information that we need in the ecosystem. Of course, this has been a major issue, especially since Deepwater Horizon. But it's true well beyond this particular area. So as a career path, I highly recommend it. There is so much work that needs to be done in so many areas. And, there are perks to working in the government as well. So with that, I will be glad to take any questions.